Hi guys, in this video we are going to learn how to draw the phase diagram for RLC circuits, parallel circuits. So in our previous video we have already discussed how to draw the phase diagrams for voltage as well as the current for RLC series circuit. Like that, we are going to see here, we are going to separate into three individual cases and we are going to analyze these three. So if you are new to this expert tutor channel, don't forget to subscribe it. Also, if you like to join in our any games, mathematical game, I have given the link of our group in the description, so you can always join that. Also, if you have any doubts or if you like to watch our previous video, I have given the link in the description, so you can always watch them too. Okay, without wasting our time, let's move to the question directly. Okay. Over here, in the previous part also I have already mentioned you don't need to memorize this, but the reason behind why I am doing this in a video, in a separate video, is to show what will happen or how the circuit will change when these three cases. So it's an overall view, so you don't need to memorize this. It's just I'm forcing this video to make and clear understanding why we are using these three, or how we can manipulate these three and get different types of circuit while using this R, L and C. So without wasting our time, let's jump out to the methods. So if you have this type of parallel circuit using Kirchhoff's current law, you can directly tell the I would be equals to IR plus IC plus IL, which simply means the inductor, the current through that inductor plus current through that capacitor and the current through that resistor would be equal to the added up the total equivalent current. Also, we can tell another thing also, the voltage difference between these R and the C and the L, all three would be equal. So you can tell these two directly if they have given any parallel circuit. Likewise, we are going to use these terms over here. So the thing is, in the previous video when we are discussing the phase diagram for RLC series circuit, we draw the current as a reference line. When I am considering this part, we are going to take the voltage as reference line. The reason behind this is, actually we knew that the voltage across these three elements are same, which simply means it's not going to change for these three. So we can directly take that voltage as a reference line because it's not going to change for these three elements. However, when we are considering the I, R and C and I, L, it's going to change for each element. So let's draw the phase diagram without wasting our time. Okay, VR, this is known as, VR, this is not VR, it's going to be V. The voltage would be common for all three. So if you are considering about the XL greater than XC, we are going to separate into three cases. One is XL greater than XC. So what we can tell using XL greater than XC? Actually, we knew that the voltage between this L and BC would be equals. So from that we can write one equation. If I use that Ohm's law, we can tell the I into XL would be equals to IL into XL would be IC into XC. If I take this SL into one side, we can tell the XL would be XL over XC would be equals to IC over IL. Actually, we knew that XL over XC is greater than 1. So from that, is XL over XC is greater than 1. From that, we can tell the IC over IL is going to be the greater than 1. So these are the main thing you need to know. So if I use that, we can tell the IC would be greater than IL. So remember, you don't need to memorize this, but if you know that XL, the impedance of that inductor is greater than the impedance of that capacitor, you can easily prove that the current going through that capacitor is going to be greater than the current going through that inductor. So that's the main point. You can directly derive that using that Ohm's law. So let's draw that. So from that we can directly tell the I is going to greater than IL. So let's draw the IR part first. So I'm going to draw the first IR part. The current from that I is going to be in the same direction of VR, because actually we knew that when we are studying the resistor circuit, we noted that the angle between the voltage of that resistor and the current of that resistor would be 0. Actually, it simply means it's in the same phase. The voltage and current are in the same phase for resistor. So we can directly draw like this one. So after that I'm going to draw that IC. You can take in any order, whether you can take that IL first and IC and IR later, it's up to your wish. So let's draw that IC over here. So when we are considering about the IC, actually we knew that IC is greater than IL, and the next thing is we need to figure it out whether IC is in the upper direction or the minus y direction. How we can find that is, actually we knew that in capacitor we can directly tell the current will lead the voltage in that capacitor. The current through that capacitor will lead the voltage of that capacitor. The phase is going to lead that voltage phase. So from that we can tell, actually we knew that this voltage is same for capacitor. Just forget this IR, the current through that resistor. If you forget that, we can directly tell this voltage is going to be same for that capacitor too. So if I draw that part over here, we can tell the IC is going to lead this voltage. So we can tell the IC is going to be in the y direction, the plus y direction. So let's draw it like this one. It's going to be IC. So the next part is we need to draw the IL. How to draw that? From this point we need to draw the IL, but we actually knew that the IC is greater than IL, and the next thing is we need to figure it out whether it's going to be in the plus y direction or minus y direction. You can easily figure it out because we actually knew that the inductor, when we are using the inductor, the voltage difference between that inductor, the voltage phase, will lead that current through that inductor. The voltage is going to lead that current by 90 degrees in that inductor, which simply means I is going to the I through that inductor, the phase of that I through that inductor is going to lag that voltage difference of voltage phase in that inductor. So we can directly tell, don't remember these two. If you forget these two, we can tell the I is going to be in this minus y direction because the I is going to lag that voltage. In other terms, we can tell the voltage is going to lead that current. So from that we can directly tell it's going to be in this direction, downwards direction. However, we knew that IC is going to be greater than IL. It's going, so that we can directly tell it's going to be like this. So from that we can directly tell the resultant I, the current, would be in this direction, I. So the next main thing you need to ask is whether this circuit is going to have a capacitive characteristic or inductive characteristic. You can easily figure it out because in this case the resultant I is going to lead that voltage. Actually, we knew that if the current is leading that voltage, it's going to show that capacitive characteristic. So you can call it as capacitive circuit. So the thing over here is, actually sometimes it would be a little bit difficult to remember whether in a capacitor whether the current leads or voltage leads, but my advice is just remember one thing. I have remembered only one thing, that in inductor voltage leads the current. In inductor voltage leads the current. I have only remembered that thing. After that you can change that and remember these things. You can recall this capacitive using that one only. So let's move to this one. When XL is equals to XC, in the previous video also we have discussed, when the XL is equals to XC, we are going to give a special name which is resonance. So we can tell it like it's going to be the resonance parallel circuit. In the series circuit also we have learned that we can call that series circuit, RLC series circuit, when this XL is equal to XC, we can directly call like resonance series circuit. Likewise, we are going to call this as resonance RLC parallel circuit. So remember the parallel circuit resonance. So we can directly tell if this is equal to XC, we can tell the IC is going to be equal to IL. So you can directly draw. The main thing is we are going to take this voltage as reference over here. Remember that the reason behind this is going to, the voltage between these three elements are going to be the same. The one thing, as this is in the parallel, you are going to take the voltage as a reference. But when you are considering about the series, you are going to take the current as the reference line, because I is going to be changed. I is not going to be changed in that series circuit. So if I draw this part, the IR would be in the same direction. There's no changes, so IR, and after that I am going to draw the IC part. Actually, we knew that IC is going to lead that voltage in that voltage difference or voltage phase in that capacitor. So we can directly tell it's going to be in this direction, IC, and the IL would be in this direction. But the special thing is we can directly tell IC is equals to IL because XL is equals to XC. So from that we can tell the resultant I would be in this direction, resultant I, which simply means voltage and I are in the same phase, which simply means it's going to have the characteristic of resistor. However, it is containing R, L and C, but it's going to have the characteristic of resistor. That's an important thing you need to remember. Likewise, if you draw the circuit diagram, phase diagram for this one, it's going to show an inductive circuit. So these are the main things you need to know, because it's something really important. If you, although you are having these three in the element circuits, there is three elements in that circuit, however it's going to show only one characteristic. So that's the main thing you need to remember. So although they are having these three, and it's going to show only capacitive circuits, it's going to show that capacity is like to be similar to the, show the characteristic similar to that capacitor. Like a capacitor is going to act like a capacitor. So these are the things you need to remember in these things. So you can draw the phase diagram for XL less than XC, so it would be more useful for you. So I'm not going to draw here. Hope this video would be useful for you. If you have any doubts, please comment it below. Also, if you have any suggestion, please comment it below so I can also improve myself. Thank you for watching.